Good morning. Today, for pre-calculus, I'm going to be covering how to graph tangent of x, cotangent of x, secant of x, and cosecant of x. I'm going to get going with the tangent and cotangent first, and in the second part of the video, we'll do the secant, cosecant. So, for graphing tangent and cotangent, it's really, and this is all doing it without a graphing calculator. So to do this, it really has to do with vertical asymptotes. Okay, so remember, an asymptote is a line that something approaches. Usually, it's a curve that approaches but never gets to. So we want to find the vertical asymptotes. So what you do is for tangent, if you remember these two things, your life will be easier. You set equal to pi over 2 and negative pi over 2, and it's the thing after the tangent. And I'll show you an example in a minute. For cotangent, you set what's ever after the cotangent equal to pi and 0. So make sure you write that down, please, because that's going to make all of this really fall into place rather easily. So in red here, I got the example. Suppose I had a tangent of 4x, right? We're going to graph that. I take the 4x and I set it equal to pi over 2 and negative pi over 2. And solve for x. Okay, so you can see I took it over here. Here's 4x equals pi over 2, and I divided by 4 to get the x alone, and I got pi over 8. Over here I took 4x equals negative pi over 2, divided by 4, and got negative pi over 8. So that's how you do these. That's how you start anyways, okay? And I'll show you what to do after that. So for tangent and cotangent, there's no amplitude, okay, because these are actually going to be vertical curves. So amplitude, remember, is the top and the bottom, how high and low the curve goes for sine and cosine. The period is going to be pi. We're going to be looking at that. And we have to find the vertical asymptotes, okay? So let me jump in. I'm going to do the basic one, all right, where, the tangent of x, just the most basic one. So that's where I take x equals pi over 2 and x equals negative pi over 2, and then I'd solve it. But in this case, obviously, x is all alone, right? So I've already got my asymptote, so it goes over to pi over 2 and negative pi over 2. Now, the tangent, if it's positive, like this one is, it goes up and to the right. So it's just one of these kind of curves like that, okay? And that's what it looks like, okay? Now remember these are the vertical asymptotes, so these are I should do that in green. The horizontal lines, vertical lines, that's why they're vertical asymptotes, that curve approaches but never actually gets to. Okay, now for this video and in your classwork, I'm really just looking for one period, okay? That's one period, but this does actually repeat. This will keep going. There'll be one of these over here. There'll be another one over here, just so you don't think that, it's just that. And if you punch that into your graphing calculator, you will see that that's what it'll look like, all right? So that's 3 periods, all right? Okay, so that's the basics. Now, there's a couple things that are worth knowing, or at least writing down. And these are the 4 things. So your basic tangent curve starts at the bottom left and goes up to the top right. And it does that over and over again like I just showed you. If it's negative tangent, then it's the other direction. It starts at the top left and goes to the bottom right. Okay? For cotangent, forget that it's over on this different spot on the x-axis there for a minute. Just look at the end behavior where it goes up and to the left and down and to the right. Okay, the same as negative tangent, in fact. And for negative cotangent, it's got the same end behavior as tangent, where it goes down and to the left and up and to the right. So those are the 4 basic curves, okay? And you can refer back to that while you're doing these classwork, and I can look back at it also as I do these problems. All right? So these are the basic. Here's another problem. These are the kind of things you'll see in your classwork here. So remember, it's always equal, for tangent, it's always equal to pi over 2 and equal to negative pi over 2 to find my vertical asymptotes. And with this, I go 5x, and then solve, right? Divide by 5. I get x equals pi over 10. Totally legal move there, by the way. Just multiply the denominator by the 5. Okay. Now you're going to see how much time I spend on this. You know, I remember I can kind of mark these off. It should be a 10, not a 2. And here's positive pi over 10. Okay, and then I'm going to put my curve in there. Now this time tangent is negative, all right, because of that negative in the front right there, which means instead of going up and to the right, I'm going to go up and to the left. And that is an important thing. So it's going to be more like, I don't think I like down. Let's zoom in a little bit, I'll draw it better. More like this here. And there we go. And you can draw in the asymptotes if you like. Really, I'm not worried if you don't, but I just want you to see them for the video here to see what we're talking about, right? So you see how that purple curve approaches both dotted lines, but never actually hits it. So they shouldn't cross the dotted lines. Okay, next one, y equals cotangent of x. So this one's different. Remember, we're not setting it equal to pi over 2 and negative pi over 2. This time, I'm setting it equal to pi and 0. So I take x equals pi and x equals 0. And those will be my two asymptotes in this case. Okay, so x equals 0 is a vertical asymptote going through there. Here is the one for pi. And then cotangent, if I look at those 4 curves, goes up and to the left. Right here will be the halfway point. Okay, and I'll mark that off in a moment. So this is what that one looks like. This one is right halfway in between. Okay, so between 0 and pi is 1/2 pi, or pi over 2. Okay, so that's where it hits the x-axis. So that's a good thing to mark on your graph as well. And there's your basic curve for the cotangent. Okay, if you have questions on that, please bring it to class. Number 4, same thing, except this time it's y equals cotangent of x over 4. So once again, I go equals 0 equals pi. I think I switched the order of the 0 and the pi the last time, but you get the same thing. So I got x over 4. So the opposite of dividing by 4 is multiplying by 4. And here I get x equals 0. Here I get x equals 4 pi. Those will be my two asymptotes. X equals 0 is still a vertical line going through 0. Here's 4 pi. It will hit the curve halfway between that. Halfway between 0 and 4 pi is 2 pi. And then my curve, once again, that was positive cotangent, right? Yep, so this is going to go start up at the top left and go down to the bottom right. And you can see how little effort that took. All right, good. Next one. All right, a little bit more. Now, the 2, let's talk about the 2 just for a minute. The 2, when we're doing sine and cosine, is very important, right? Because that's the amplitude, all right? So the amplitude being 2 or negative 2. With tangent and cotangent, it really doesn't make much difference. It's really just about the same thing. I'll show you that at the end. So you basically ignore the 2. What is important is that it's negative, because that's going to, you know, determine whether it goes up and to the left or up and to the right. Okay. So I start out the same way. I go 3x equals pi over 2, and 3x equals negative pi over 2. And then I'm going to divide both sides by 3. And I get x equals pi over 6. X equals negative pi over 6. And there's my two asymptotes. So it goes right here to negative pi over 6, positive pi over 6. Put my dotted lines in there. Put my curve in there. So that was negative tangent, which means it goes this way. And that's what it's going to look like. Now, I'll show you quickly on the graphing calculator. This is the difference between y equals negative 2 tangent 3x and y equals negative tangent 3x. you see that there's a little more angle. It's a little steeper. The red line's a little steeper than the blue line, which is the red line is the one with a 2 in it. But otherwise, it's really about the same. And I zoomed in a little bit here, but if I zoom out, you'll see that, the asymptotes are the same. It's just a matter of how quickly they get there. I know that kind of probably makes you, that's a little too much for my eyes at the moment too. But anyway, that's the difference between those two graphs there. And it's pretty small. So anyway, I just wanted you to see that's why I'm not making a big deal out of the 2. Okay, next. So this one, same idea, right? I'm going to kind of ignore that 1/2. The only thing that I am concerned with is that it's positive. So, but I'm going to take, this time I've got a couple things over here. It's not just an x. So I go x minus pi over 2 equals pi over 2. And x minus pi over 2 equals negative pi over 2. So, just like all the other tangent ones, set it equal to pi over 2 and negative pi over 2, and then solve it. All right, so I'm going to solve this, and if I add pi over 2, I'll get that x alone. 1/2 pi plus another 1/2 pi is a full pi. If I add pi over here, pi over 2 over here, excuse me, negative pi over 2 and positive pi over 2 is 0. So there's my two asymptotes. It's 0 and pi. So here's 0. Here's pi. It's kind of sloppy. Okay, and then my curve is going to go right in the middle of there, right? And halfway between 0 and pi is pi over 2, or 1/2 pi. So tangent was positive, which means it starts at the bottom and goes up to the top, to the right, like that. And that's what your curve looks like, okay? Just another quick reminder, that is just one period. There will be another one over here. There will be another one over here, but you don't have to graph all of those unless they specifically ask for more than one period, okay? Anyway, there you go. And if they ask for 2 periods, you could do either another one on the left of it or another one on the right. It really doesn't matter. Okay. All right, so that's graphing tangent and cotangent. Next, I'm going to get into why graphing secant and cosecant. So when we do this, we're going to start out the same as graphing sine and cosine. So a reminder that cosecant and sine are the inverse functions, so those go together. Secant and cosecant, cosine and secant are inverses, so those go together. So up here I see y equals the cosecant of x, which means I'm actually going to start by graphing y equals the sine of x, okay? So with this, the amplitude is what's in front of the sine, which is 1. Okay, the period is 2 pi. Okay, so I'm going to start there, and so here's 2 pi, and I'm going to break it into quarters. Here's 1 pi. Here's 1/2 pi, and here's 1.5 pi, which is 3 pi over 2. Okay, so the amplitude, it goes up to 1, down to -1, and I'm going to graph this. All right, y equals the sine of x. So the sine, it starts at 0 and goes up and then down and back up. So, and if you're missing any of that stuff, go back to my last video. There's another video on how to graph sine, cosine. So it starts here, which means that I'm going to change colors. It starts there, which means it ends the period at the same spot. So start there, goes there, and for the sine, it's going to go up to the top, back down to the x-axis, down to the bottom, and then back up to the 2 pi. So that's what that looks like. Now, if I'm doing the cosecant, it's actually, this is kind of neat. It's the other part of this. So anywhere it hits the x-axis, I'm going to put an asymptote, okay? Anywhere it hits the x-axis, put the asymptote there. I'm going to actually write that. Now the rest of the curve, in this case it's the cosecant, will be from here and here. It will be up here, going towards the asymptotes, and down here, okay? Now, really the best way to do some of these is simply to have those other ones be in dotted. Okay, so if you go like this, especially when you're doing classwork, you know. So this is what the sine of x is, and you kind of dot that one in there. And then the green one is actually what your graph is for the cosecant. Okay, so the green is cosecant, the pink is the sine. So you use the graph of y equals sine of x to get the cosecant graph. Okay. All right, so that's the first one. Second one, y equals secant. So secant and cosine go together, which means if I graph y equals the cosine of x, once again, the amplitude is 1, period is 2 pi. So I'm starting over here, going to, here's 2 pi, here's 1 pi, pi over 2, 3 pi over 2. So there's my 4 things. Goes up to 1, down to -1. Spent tons of time graphing that so far. Now the cosine, remember the cosine starts up at the top, which means ends at the top, and goes down at the bottom, and hits the x-axis halfway through. So I'm going to make this dotted once again. Okay. Now let me graph which means my asymptotes will be here and here. So here's one. Here's another one. Here's the third one. So you know there'd be another asymptote over here. Let me draw those in. There'd be another one over here. There'd be another asymptote over here. Okay. And that's the red there is what your graph would look like for y equals the secant of x. Okay, so those are the basic ones. Let me do a couple that have a little bit more to it, different periods, different amplitudes, etc., etc. 9. This one, period. Remember, period is you know, that 3 represents the period, the absolute value of that, which means period is 3. My amplitude, in order to find the amplitude, I go 2 pi over b, so it's 2 pi over 2, which means my amplitude is pi. So there's my period and my amplitude. I'm going to start there. So goes up to here, goes up to 3, down to -3, and my period is pi. So I'm going to break that into quarters as usual. Here's pi over 2, 3 pi over 2, pi over 4, not 3 pi over 2. It's halfway between 1/2 and 1 is 3/4. Okay, so there's my markers. Now let me graph my curve. So that's a cosecant, which means the inverse of cosecant is sine. All right, those two go together, which means I'm starting at 0 and I'm going up to the top, back down to 0, down to the bottom, back up to the top. Put some dotted lines here because I'm actually going to be doing the inverse of that. Okay. And then I can draw in my asymptotes, right? The asymptotes are anywhere it hits the x-axis, that curve. And now I'll draw my inverse function in there, which is like this. And there's the answer. All right, so that's y equals 3 times the cosecant of 2x. Moving right along. Number 10. Next one. So this one's y equals -secant of pi x. So I'm actually going to start with the inverse of the secant, which is the cosine. So if I start with that, my amplitude is what's in front of the cosine. There's an implied 1 there, and it's the absolute value of a, for anybody's forgotten, which means absolute value of -1 is +1. And then if I am looking for the negative cosine, all right, so period is 2 pi over b, and in this case, b is going to be pi. Okay, so if I do that, then the pi's cancel, and my period is 2. All right, and it's negative. So cosine usually starts at the top of the curve, but in this case, it'll start at the bottom. So we said the amplitude is 1, so it goes up to 1, down to -1 and goes over to 2. So I'm going to break it into quarters, which would give me 1, 1/2, 3/2, and there are my 4 points along the x-axis. Okay, so cosine, we said starts at the bottom. If it starts at the bottom, it ends at the bottom, goes up to the top. Cosine just always looks like a bell. It's going to hit the x-axis over here. So I'm going to do some dots here. Okay, so I got the cosine part. Now I need the inverse. So the inverse has to do with the high and the low points, all right? So let me change colors so you can see it a little better. So here's the halfway. Reminder, the asymptotes are wherever it hits the x-axis. And then the high and the lows here will give me the inverse, which is the secant. So that's the negative secant of pi x, all right? And moving along, here's my last problem of the day. And it's got that -1 at the end, which is a vertical shift. So this one's got a couple shifts. It's got a vertical and a horizontal shift. So it's going to go pi units to the right because of the minus pi there, okay? And it's also going to move the -1 over here at the end is going to move everything down. That's a vertical shift of 1. Okay, so we talked about, we got the 2 shifts, and I'm going to talk about the horizontal shift to the right first. Now usually, suppose for a minute, forget the -1 at the end for a minute. If I had just y equals the sine of x, these would be the critical points, right? The important ones where, you know, it'd start at 0, it would go up to pi over 2, back down to the x-axis at pi, down to the bottom of the curve for 3 pi over 2, and back up at 2 pi. So if I shift all of those points to the right pi units, I'm going to add pi to all of these different points, okay? And what I get is 0 plus pi is pi. Pi over 2 plus 1 pi is 3 pi over 2. 1 pi plus 1 pi is 2 pi. 1 pi plus 3 pi over 2 is 5 pi over 2. 2 pi plus 1 pi is 3 pi. So these are my new critical points, okay? So I'm going to go put these on my graph, and I'm going to start over here at pi units. So here's, I got to get all the way up to 3 pi, 1 pi, 2 pi, 3 pi. And then I got all the half ones in there. Okay, so there we go. So I'm going to start here. Now I got to get the amplitude on here as well. So I'm going up to 1, 2. Let's see why I'm putting the extra numbers on here. Okay, so once again, I'm going to do a dotted one for the sine, okay? And forget the -1, I'll do the -1 at the end, okay? So the sine, it starts at 0, right? Which would be here. Goes back down and back up. So usually the sine will go, and this goes up to 1. Back down here, like that, all right? So that's what my sine curve looks like, which means usually, you know, my curve, usually my inverse would go like this, right? On the opposite sides of that. However, I got the -1 now. So what I'm going to do instead is I'm going to take that point, I'm going to move it down 1 unit. So instead of going there, it's going to go here. Same thing down here. Usually it would be here, but I'm just going to move it down 1. So instead of starting at the end of the curve, it's going to end 1 more unit down, okay? And those will be what my graph of y equals the cosecant of x minus pi minus 1 is, okay? And I kind of like it that way, you know, it's just make that vertical shift at the end of the whole graph graphing process, okay? All right, so anyway, that is all I got for today. Guys, have a marvelous evening, and if you have any questions on this, please bring it to class. Thank you very much.